Okay, let's begin. Welcome back to the stream. Welcome back to the channel on YouTube and on Twitch. I really appreciate it. Really appreciate you hanging out with me this Saturday afternoon, this chilly, cold Saturday afternoon. I really appreciate it. Just a little refresher. Yesterday, we did some design work, updated the PCB, the schematics, kind of did some of the stuff we wanted to get done. We're going to kind of put ordering the revised board on hold while we do some more testing to make sure we don't need to do anything else, make sure everything we're happy with everything that we're doing. And I figure we will start going into doing some more testing by building the one rig that'll by building a little rig that'll solve two problems with one at once. One, it'll solve a testing methodology that we can actually continuously run a stepper motor and just have it drive just to see how the system reacts, to make sure it can handle it long term. And then we'll also at the same time be testing a TPU 3D printed GT2 timing belt, just to see how it stacks up. So let me get my camera going here, and so I'm going to warn anybody who's viewing this is going to be an extremely chaotic, crazy video. You'll be questioning your sanity. And that's the way it rolls with me. So let's see here. We have the camera, and you'll see an assortment of junk on my desk, my workbench, stuff I've got set aside to, start working on this. So obviously we have the stepper motor driver box, the board in here. Perfect. We'll set that aside. This little gem is the 3D printed TPU GT2 timing belt, printed with the AMS the TPU for AMS for the Bamboo 3D printer of their ecosystem. So I think it's A95. I think that's the stiffness of this TPU. So it's still nice and flexible. It's still a nice little flexible material. So we're going to be trying to build something to test this, to drive it back and forth. So like I was saying, I picked up a stepper motor mount, which should work. We have the stepper motor that we want to use right here. It's already got the GT2 pulley on it. And I've tested it. It meshes just fine. It looks beautiful on there. So what we're going to attempt to do is just smash something together. So this is a gantry I picked up for this project. So we have a gantry. I have a whole bunch of assorted mounting brackets, parts, screws, a whole bunch of different stuff. We've got a couple of switches that we're going to be using for our limit switches. We're going to wire them normally closed because we're going to be looking for basically lows. It's a kind of a safety mechanism. So if the switches get damaged, they're not operating, the system will assume that the switch is engaged and basically act as if it hit that, and it won't run in that direction. And if both of them are engaged, the system will have a kind of like a stopgap, like an error in there. And that's where did I put those parts? I have a whole host of other parts I want to use for this. We'll probably end up doing some 3D printing, some design, making some custom brackets and stuff, because, and why not? This will be kind of fun. So I've got some control switches, some indicator lights. These are just 24 volt LED These are just indicator lights. So I bought a couple, a multi-pack of them, for one thing, to build the trainer box for the PLC that I'm going to be working with. Then unfortunately this one's red, but hey, we'll take it. It's a latching button. We're going to use it for enable. It's kind of a shame it's red. I mean, I might steal the green one from the PLC project, so I'll just show you this is going to be the control box for it. It's going to have like a selector switch, and it's going to be basically two different, and then a couple buttons, couple status lights. So you know what? I will borrow the green switch from this, and I will just replace it or buy a new one down the road. So we'll have like a red indicator light for a fault, green indicator light for, hey, everything's running good. That way we can utilize the controls on the stepper motor board. So yeah, I'll be kind of borrowing different things from here. Nothing wrong with that. We'll do what we got to do. We'll make it work. Because I wasn't anticipating wanting to use these buttons and stuff for this test fixture. So I'll just buy more if I have to. They're not that expensive off of Amazon. That way we can have this test fixture a little bit more permanent, because we might be able to buy other TPU versions, like different softness, different flexibilities, and test them out as well for durability. So we'll also use not only the limit switch to know basically when the gantry hit the extent, but also we'll use one of them for the counter to count cycles. So every time the limit switch is activated, we'll count that as a cycle. Bing, 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 things like that. So I've got these limit switch mounting brackets I threw together a while ago. I've had these for a while. I designed in Fusion and laser cut them out of 6mm plywood. They take M2.5 machine screws. So got all that. We're going to be powering this guy. So I had to tear apart some stuff from my other project that I've been working on to kind of scavenge parts for this build, which is perfectly fine. I've got basically a Meanwell. It's not really Meanwell. This is Delta Electronics. Same thing. It's a 24-volt power supply. What is this guy capable? 13.3 amps. So this was from a old 3D printer I think I had salvaged. So we'll just use this. Design this bracket to hold this guy here. That way we have our hot, our AC mains for the power supply, and it's fused, so that's perfect. So it's going to be a mess, and you're going to probably be questioning your sanity. You're going to be questioning why you're even bothering watching me. And you know what? That's perfectly fine. That's just the name of the game when you step into my world. So we're going to try to be basing it around C-channel extrusion. This is from another item that I had. So I was testing out a CNC router mill. I had one. And I wasn't happy with the DIY kit. It just wasn't stable enough to do what I wanted to do. So I think at the end of the day, I mean, obviously it's not that I think. I just went ahead and just tore it down, salvaged all the components, and just set them aside so I can build projects like this. And if I do want a CNC mill, I think I'll just buy one of the pre-made that they're working on right now, like a CNC machine. So that'll be down the road. Yeah. There's other equipment that I'm looking at right now that I'd rather get than a CNC machine, to be honest. There's that, I can't remember the brand name, but that new printer that uses UV curing inks that I would love to acquire. I can't remember who makes it. It's been a while since I looked into it, but I watched some videos of this thing and it looks sweet. And I could just imagine the potential for making custom printed labels for devices like this, where I could just design it and print it straight onto the box with UV curable ink. So that would be awesome to be able to do. So that is something I'm going to definitely work towards in the future. Okay, so we've got this. We've got the C-channel extrusion. So obviously we have the gantry. It goes on here. Nice and neat. We're not going to obviously use the whole length, but that's fine. Again, this is going to be like just a project that's Frankenstein hodgepodge together just to get it to work. Because we're going to have to attach the drive belt to the gantry. We're going to have like an idler in the back and just have to stick out here to where we can basically drive it with a stepper motor. So obviously we're going to have to get a whole bunch of different things to work and fall together, and who knows how this is going to work out. It's going to be crazy. It's going to be insane, but you know what? It might actually be entertaining and fun. So yeah, like I said, it's a universal stepper motor mount, which I found really nice. Now the only thing I'm not happy with, and that might be kind of interesting, is there's not going to be any access to adjust the motor after the fact, after we get it mounted and installed. So that is going to be a negative. So we're going to have to do our best to line things up and fidget around with it a couple of times before we get things to work. So I know that's M3. I think these guys should work. Let's make sure. You guys might be too long. So in case you're seeing this, basically I've got one of those divided part things that have these like plastic polypropylene, I think, drawers are only divided in half, and I just kind of designed my own replacement drawers where I can divide them my own way. And then these dividers, washers and stuff would often slide back and forth, and I hate that because the type of material it was just a difficult thing to super glue. So I just went full ham and designed my own drawers for it and 3D printed them and made a bunch of them, and even kind of color coded M3, M4, M5. Kind of the different sizes are kind of color coded. They're all like, all the M3s are this blue or a blue color. Yeah, so it's a little crazy. So not sure. We're gonna need these guys. So let's make sure we have the screws to tie all this guy together. All right, make sure we can put this guy on. Hopefully, you know what, I'll just grab one of these wide washers. And we're just gonna kind of, there we go. That'll work. There we are. One screw will be fine. So yep. I've got hardware that'll hold that on there. So we'll just use one to hold it temporarily. Beautiful. So the biggest thing really isn't the gantry, because I think we can kind of use some pieces and kind of force the belt to kind of get bolted to the gantry. We can use the T-slotted nuts and kind of grab the belt on both sides, which should work. Which we can do, which I think will be fine. Worst case is we just have to kind of 3D print something that kind of clips it together. We'll see how it all pans out. The biggest thing is to get the stepper motor mounted to the end so I can get the drive belt lined up properly. We'll have to figure all that. It'll all be fleshed out in the long run. We'll have to see what we can do and how it works. I have some extra pieces of extruded aluminum that we're going to work with. Again, things are going to get a little crazy. Not perfect, but hey, you know what? Nothing is. And I think if we, I think if we do that, maybe. Yeah, we might be able to do something like this. Kind of like this. And then we can have the motor mounted here. Not perfect. And then the power supply, we can kind of figure out how to get it mounted in there. Kind of maybe back here. Maybe we could throw some kind of control panel together. Who knows, to hold the buttons and the switches. And then for the limit switches and all that, I've got this cable. It's the cable I was talking about. It's basically a 3-conductor. We'll wire up the limit switches with this stuff because I like using it. And this is the stuff I want to run across between the workshop and the office to get the RS-45 connection across. So I think this will work. And the great thing is if I accidentally lose or damage this belt, I can always print a new one. I'm not worried about that. So I figure this guy can go here. The power supply. I can kind of just do some rearranging and kind of put it back here or something, as long as it's out of the way of this guy. We'll kind of figure it out as we go. Yeah, we'll kind of figure it out. Not terribly worried. This is kind of how I normally work anyway, is helter-skelter. Everything's just like crazy. So then I've got these, they're studs for the extruded aluminum. So, and they're drop-in, so you can drop them in. That way you can use bolts instead. So they're kind of like, you know, just a studded version of a T-nut. So these are pretty great for depending on what application you're looking for. So I was thinking is I could use the longest one, which I already have one set aside. What's cool is as you tighten them in, they're designed so you kind of drop them in and rotate them, so you don't have to worry about dismounting anything else. So I figures I can do that and have the idler like right here. So the drive belt. Yeah, it's going to be interesting. And this is how I design. This is how I work. I just grab stuff and I start working with it. I know there's other guys, other people that like to sit there in their CAD programs and design, and I just don't work that way. My brain does not work that way. I work better when I have the stuff in my hand and I can just start designing and just slapping it together. And I think, honestly, everything would be like at the right height. Like this. That might actually work. Get the tension on there. All right. You know what? I think we might actually be onto something. So, and the cool thing is, once you loosen these guys up, you rotate them. I think it's like a quarter turn. Yeah, quarter turn counterclockwise, and they pull right out. So again, no reason to disassemble anything else in your setup. I like that. And what's cool is because of everything I bought all this hardware, Came with a bunch of screws and a bunch of brackets and a bunch of different things. Really, really beefy corners that we can use to kind of just tie things together here. Yeah, I know they're corners, but they work great for tying things like this together. Because then we've got these guys, which are great for, you know, kind of wings and stuff, but not going to be able to use those for this. And I've got, I don't know if these guys are long enough. I've got a whole plethora of screws and hardware. Wow, those guys are beefy. Yeah, I have to make sure that they don't interfere. Okay. With the extent of where this guy can travel. So we might use these little guys. I have a few more I can go and grab if I need them. Yeah, I love working with extruded aluminum. This stuff is fun. It's like Legos for adults. Nobody looks at you funny when you work with extruded aluminum. Everybody's, yeah, okay, I know what you're talking about. So it's pretty fun. All right, various tools everywhere, various hardware pieces, various screws. That might be too long. No, that's fine. Get this guy going. I'm still all over the place. I'm actually honestly surprised that people do tune in and watch what I do and watch my videos on YouTube. I am honestly surprised at that. Because I am literally all over the place. Don't really plan effectively for some of this stuff. Electronics is one thing, but mechanical stuff like this. I mean, even electronics, I'm kind of the same way. I throw together on the breadboard without a plan. I just start working. To see if the gantry misses that. If it does, it does. That'd be great. Oh yeah, gantry will slide right over those brackets. So I kind of like these other cast ones. They're kind of lower profile. But I think we might actually have something that'll work here. Crazy looking, but you know, not going for popularity content. Not going for looks. Mm-hmm. All right. Now we're getting somewhere. Yeah, I do. I really appreciate you hanging out, taking time out of your weekend to hang out with this crazy old man with his crazy ideas and his crazy projects. It's actually a lot of fun. And oddly enough, this is a lot of my weekends. This is what I prefer to do. Work on stuff. So I'm just bringing you guys along for the ride with me. And it's honestly a lot involved if you want to design and make a product to put on the market. Especially if you want to test it as thoroughly as possible. So I imagine at some point we're going to have to do a video of doing some design work to print with Fusion or in Fusion, so I can 3D print like a control panel to hold the buttons and the indicators and stuff. There we go. Yeah. All right. Now we're looking kind of funky. Now we're looking like something weird and crazy. All right. Hey, you may not be able to tell by just watching, but it's getting a little, you know, it's got some heft to it. So we'll grab a couple of these guys. Let's see what we can do here. Go and open some of these screws. Why not? All right, beautiful. That away. So I'm thinking is that guy on that side, this guy on this side. If it don't work, it don't work. But again, we're just mainly moving the gantry back and forth. That's, you know, maybe we want to figure out how to load it. That's a problem for later. But yeah, I don't know how well this is going to work. Yeah, we may have to. Oh, wait a minute. Nope. No. I mean, we could. You know what? Let's try that. We'll just give it 2 tie-down points. Be kind of weird, but you know, hey. Kind of tie it down at both ends. So something 3D printed may be better in the long run. Away a little bit, where it's not going to explode or cause me a problem. This might be a little tricky, but that's fine. That'll work. Cool. All right, so we grabbed it there. Gotta do the same here. 2 of these guys. Grab some screws. Grab them up. All right. Yeah, we'll make adjustments if we have to. We might ultimately still design something and 3D print it. That might actually work with just the one. That's actually grabbing it pretty good. All right. So that will help hold our gantry. Clinches the drive belt to the gantry. So, kind of put this guy in here a little bit. This is going to be the fun one to try to figure out. because we also need our stepper motor. Yeah, I hear you, little cat. I hear you. So let's kind of figure this guy out. Right. All right. So this travel's not going to be very, it's not going to have a whole lot of travel, but I think we'll be okay. Yeah, actually, that would give it a little bit more travel. So then if this guy goes in here, kind of right there. This guy out of here. Yeah, I don't know what happened to my one wrench. My one combination wrench that the right size for this. Probably set it down somewhere and completely forgot where I did that. But hey. Hey, go on there. No, not on the threads, but on the bolt. You goofy little thing, you. There we go. Drive you nice and tight. There we are. Now I have to figure out how to space this guy, the idler, to be more in the center. The motor will be easy because it's got the offset, the slots. This guy is going to be a little harder, so we're going to need let's see what we got. And a mysterious box of hardware. Bearings, I've got washers, bunch of junk, I don't know. Parts I salvaged from when I tore apart the previous 3D printers and other such stuff. Leftover bearings. What the heck? Huh. Now I'm gonna need probably like a shim. Those guys are just a little bit too far off center. So let's see here. Grab a couple of these bearings. Grab these guys. Maybe another washer in there, and let's see how she looks. Another reason why I end up saving everything that I can. Still a little bit off. Maybe another washer. Oh, that's not that far off. If I had not another washer, maybe another one of those washers. Maybe. Might be too thick. I mean, we might be okay with a little bit of play, but That is closer than it's been, I think. Yeah. All right. So now let's see here. Let me get the, okay, I got like a little shim type washer. Be able to put on this side to space that out. Too big. All right. All right, so let's see here. The stack's not going to work like that. That's not really going to shim it out that well. All right. Now the other thing I can do, washer, another, oh, those guys. See if I can those bearings. This guy free just in case. Now, what we can do here, let's do something completely insanely different. Okay, we're going to kind of make our own adjustable setup here. Yeah, that'll work. Okay. You know what? How much better this will be, but hey, it's worth a shot, right? Yeah, it's fine. I have more brand new hardware laying around. I just like to just try to use what I have. Okay. Okay, those guys aren't spinning at all. No. Probably the little tiny shims, and I don't know where my shims are. In here? No. Not there. Yeah, so I need some shims. I should have some, which is kind of funny. To go between the washers and the bearings. I have to have some from what these guys are from. I mean, worst case is we have to just kind of design something that we can 3D print. That's way too small. That's like an M3 or M3. That might actually be one. So That might actually work right there. Might just need a regular flat washer. Swap. I'll grab a new part if I have to. Okay. Oh, that might be the shim I was looking for. Oop. Oop. Yeah, I don't know how well this is going to work. Don't know. Not yet. It's almost like the stud's a little too short. I have to come up with a different solution to the problem. Wish I could have figured out what I did with my wrench, but the actual tool for this, but so there we go. There we are. Bearings are turning freely. Oh. All right. That unstuck. All right. Okay. We are looking more beautiful by the minute. That might actually work. Yeah. Okay, so that'll hold up back there. Let's pull this guy apart here. So this is going to be a little tricky. And I mean a little tricky, because we're going to kind of need to getting the tension set is going to be a pain in the butt, since I can't directly get underneath the motor. Let's get the so let's kind of at least start by solving the first problem, and that's getting the motor down. Now I have these short enough for this guy. So long / short enough, I guess. Doesn't need to be long enough to clear through here. Are you kidding me? No. What kind of motor mount are you? You're not set up for M5 hardware? What kind of crack smoking are you? Seriously? No. Oh, we've already run into a first major failure. What will fit in you? Oh. What? Okay, you were supposed to be for this particular size. Let's see. Okay. M5. Oh, yeah, you M4. What in the world? What kind of crack? Okay, M4. So let's try something here. Two 10 millimeters. Might need 12 millimeters. I'll grab them just in case. Got a couple washers. A couple lock washers. Okay, I don't know what kind of crack the seller was on about this, but yeah, the universal motor mount my rear end. Kind of crazy sounding. All right. Yeah, there's no way that's going to thread in there. I don't have M4 size. Because the only thing I can do is to design my own motor mount and 3D print it. Woo, hooray. Not something I am looking forward to doing. Or we can hack and slash this and see if we can make it work. Grab the next nuts. And that is more along what I'm trying to do, but will the motor even install? Because I'm telling you, this is kind of ridiculous. All right, the motor does install. Wow, without M4. Okay. One problem solved just to run into another, huh? Story of my world. Let's see, how's that? That actually clear it. I mean, oddly enough, that clears it. Oddly enough. That does go in there. All right. Okay. 12 millimeters too long for this, so 10 millimeter may actually work. Okay. Let's get inventive here. Let's get crazily inventive. Wow. Not what I was anticipating. Oh. Can I actually torque that guy down? Or will this thing become a total failure? Okay. Most of the way torquing down. Because I really don't have an effective means of opening up these slots at all. Now, I think they do make M4. Maybe if I get rid of that lock washer, that is kind of being a hindrance more than anything. Okay. Actually, I think it would torque down. Oh. That is interesting. So we actually have something that works. We have a weird solution to our problem, but it's a solution still. So no reason to despair. We adapt and we overcome. Okay. So using M4 hardware in ways that wasn't meant to be used, but hey, you know what? Let's do it. So now we have 2 axes to worry about. Okay, so as far as tensioning the motor, you know what? Let's be a little crazy here. Because there are ways we can get this drive belt on here. That's not a problem. Is that too tight? So let's say right about in there. And then realistically, the back side of the motor mount, even with all right, so that should work. All right. Worst case, this thing doesn't work, and we have to kind of come up with a new game plan moving forward. Best case is it works, we get a victory out of it. Hooray! Get that problem solved. Now, do I want to... no. Off of the wires, kind of do something crazy, kind of bring it around this way. All right. As far as getting this guy on, that's going to be interesting, but we can do it. Grab the M3 hardware. Oh, wait a minute. Should be a washer in there too. So, all right, those guys, let's grab locks and a couple of wide washers. Yeah, so technically, so you have your standard M3 washer, and then you have what's commonly referred to as a wide washer. They're just exactly as their name states. They're just wider than the default. They're really handy and great to use for slotted applications like this. Yeah, so I have a feeling tomorrow's video will be, session will be a continuation of today's, which is what I expected. I didn't expect to be done with this build in one day. I really did not. Especially running into these problems. Loosen these guys up a little bit. Give it a little bit of play in the motor. Come on. Come on. There we go. Now, we might have to find a way to tension this a little bit better. We might be able to loosen this guy up and force it back. Without the right tool, it's going to be difficult. All right. I mean, we're getting somewhere. Yeah, the whole range of motion is not going to be that great on this guy, but let's see here. Oh, nope. Let's see if we can, well, we've got this. That's what we can do is kind of push this a little bit more towards out here. Right. Whee! Bearings are still free. Get you guys in here. Oh, come on now. Go back on there. Come on. There you go. Woo! Yeah, this would be a little bit easier with the right tools, to be honest, but hey, you know, again, we work with what we have. I gotta figure out what I did with the right tool for this. Hello? Oh, no. Go, got that. You know what? Yeah, I don't like using pliers, but sometimes. There we go. All right. I somehow think that's, yeah, it's worse. It's a little worse. So what we might need to do is jump the belt, loosen it up. And pull it back. Tighten it down. And then realize we're too tight. Yeah, a tensioner that would be easier would probably be the best bet. But we're in between where it was and where it is now. All right. There we are. Well, you know what? It'll work. It'll be first pass prototype. We are first pass prototype ready. Not the ideal situation. May want to do something better. Actually have it mounted here in the center. Not entirely sure yet. I mean, that would be accomplished with just a simple 3D printed clip. Yeah, the travel's going to be very limited. I wish I could have made this belt longer, but unfortunately I couldn't. So there's a parametric generator that you can use make these belts. Maybe I'll see if I can play around with it instead of having it looped where it's looped back on itself. See if I can do it so it can like maybe kind of snake it on the build tray that way, because then we can just kind of combine it up here with a 3D printed bracket. As far as getting any kind of tension adjustment, yeah, that's gonna be tricky. But that feels like it'll work. So then we'll have basically a limit switch kind of wired up to this kind of mounting bracket, you know, like this, and it'll be tied into here, and then we'll catch the extent. Maybe we can do it this way and catch the extent. Nope. No way we're going to be able to do that because of the gantry wheel. But it's fine. And then we'll have one basically back here on the other side for the extent of the other direction. So it'll basically toggle between the two. Like I said, not a very long range of motion. Honestly, if I could do a longer, I'll look into it. If I can do a longer 3D printed belt to where I could cover this whole C channel, then we can definitely do something better. Because then we can come up with a better idea for this, even when we have to design some kind of bracket that we can put at the end and 3D print. Something we can slide it out to handle the tension. That way we don't have to worry about the motor. It can be, you know, however it wants to be, you know, in its happy self. That won't matter. So yeah. So I think that's what we're gonna, you know, like I said, I'm gonna look, see if I can get longer, because then if we can have a longer travel for the belt, that'd be even better. Then we can do something much better with the testing. Well, look, I'll see what we can do. But this is a start. It'll at least give us something, some way to test these 3D printed belts. And, you know, it's something we can start developing the firmware for the control box. I mean, the other thing about the travel being so limited, I mean, we'd find all kinds of ways to be able to mount and control everything. So I'm not terribly worried about all that. And if we could, yeah. So we'll look into it. We'll see what we can do. But I thank you very much for hanging out with me this afternoon, giving up your Saturday to hang out with this crazy old guy. But we're making progress. Doesn't look the prettiest, but it should function. Again, such a very narrow range of motion. But it's fine. The good thing is I've got an unlimited number of these I can print. I have material, so I can print these belts out all day long. I'll see if I can make a longer one. even if I can get a little bit longer than this to fit on here, maybe to give a little bit more travel, we may end up having to, I may just go ahead and design a bracket for this off camera just to get it done. Just something, that way we can kind of get some of the tension off of it this way, kind of in the center. Because maybe if we can get it to drop a little lower, more in line with the actual belt, we could get a little bit more travel distance as well. But hey, you know what? I'm happy with the fact that it at least it works. Yeah, at least does something. It's here. And then we'll start the firmware for this guy. Depending on how tomorrow's video goes, what I find. And if I could do better, bigger 3D printed belts or whatever, we'll figure all that out. Maybe we'll be able to get this firmware for this guy started tomorrow or Monday, hopefully, Monday evening. We will see. So thanks for hanging out with me. I really appreciate it. It's been a lot of fun so far, and I hope you guys are still entertained by this and enjoying the process, because this is the way it goes. Designing test fixtures and building them are the name of the game when you have a product you want to put out there. And because you want to make sure it works before you sell it to other people. Because that's the worst thing that ever happens. You can design a product, you can just put it together and put it on the market and sell it, and next thing you've got people complaining like, hey, it doesn't work. Well, it's because you never tested it. So you know what? That's what we're doing. So thanks, take care, and have a good rest of your afternoon. See you tomorrow.